Okay, now we are going to talk about application of vectors in 3D. We are going to start with angle between two lines, angle between a line and a plane, and also angle between two planes. And then after that, we are going to talk about collision, and we are going to talk about shortest distance. All right. So how do we actually look for angle between two lines? Okay, I think by now you should be able to tell that, like, vector equation of a line is to be given in the form of r equals to a plus lambda b. Okay, r being any point on the line, x, y, z, okay, a being a specific point on the line, so it must be given to you, lambda being a parameter, and b being the direction vector that is parallel to the line. So let's just say you are given two lines, r equals to a plus lambda b is one line equation, and r equals to c plus mu d is another line equation. So how then do I look for the angle between these two lines? Very easy. If you were to draw the graph, you're going to see that, one line will give direction vector of B, another line will give direction vector of D. The angle that I wanted between them would be what I call theta, right? So I'm going to make use of dot product, where I'm going to go B dot D, it's equivalent to the magnitude of B multiplied by the magnitude of D, and then cos theta, and if you were to rearrange accordingly, that is when you will get your theta to be the angle between two lines. Yeah. So other than getting theta like that, okay, theta over here, if you were to look at my diagram, okay, it is actually an acute angle. Can it also be an obtuse angle? Of course can. 180 degree minus theta will give you another angle, and this angle would also be the angle between two lines, because this is my B, that is my D, and hence it could be either theta or 180 minus theta, depending on whether the question wants the angle to be in acute or obtuse. Alright, if it is not stated in the question, whichever angle that you leave your answer as, it is fine. Alright, and what then about angle between two planes? By now you should know that r times n equals to a times n is the vector equation of a plane. R is again any point on the plane, so it can be x, y, z. What then about a? A is one more time the specific point on the plane. Alright, it must be given to you. What then about n? N is simply the normal vector to the plane. Alright, normal vector to the plane. So I've got two plane vector equations. One is r times n1 equals to a1 times n1. Another is r times n2 equals to a2 times n2. So how then do I look for angle between two planes? I got to simply look for the angle between the two normals. Why is that? Okay, look at this graph over here. Okay, look at this diagram over here. I've got plane 1 has got a normal vector of n1. Yeah, and I have got plane 2, it has got a normal vector of n2. Do you notice that the angle between the two planes, which is theta or 180 minus theta, is actually equivalent to the angle between the two normals? Yeah, so to look for angle between two planes, it is simply equivalent to finding angle between the two normals. Alright, so what then about the third one, angle between a plane and the line? This one you got to be a bit careful. Alright, so I have got a line, r equals to a plus lambda b. I've got a plane, r times n equals to d times n. Okay, d is simply any point on the plane. I just didn't want to repeat the a over here, hence I let it be a d, but doesn't matter, it is still what do I call a position vector that is on the plane. So how then do I look for the angle between the line and the plane? Let's look at this diagram. I've got a plane P. I've got a normal vector of n. I've got a line with a direction vector that is parallel to the line to be B. So what can I actually use to look for angle? It is just n, which is the normal vector to the plane, and also b, which is the direction vector that is parallel to the line. Hence, I'm going to use dot product, and therefore I'm going to get theta. But theta is actually the angle between the normal of the plane to the line, you see. So what exactly is the angle between the plane and the line? It is actually here. Line is here, plane is there, and this is the angle I wanted. Hence, angle between the line and the plane is simply 90 degree minus theta. Alright, and that is about angle.